Okay, I want to be able to talk to you in this video about how I would use completing the square in situations that would be kind of difficult to actually use completing the square. The times I would want to use completing the squares if I have my equation in standard form, and if I have a is equal to 1, if my b is even, and that I can't factor it. If I can factor it, I'm going to factor it. I'm not going to do any other work. If my b is odd, it's going to make it too hard to find that half of b and then square it. It just gets really messy really quickly. And if my a is not equal to 1, I actually have to divide everything through first by my lead coefficient. So let's look at that on this problem. You can see here I have that 2 in front of my x squared term. That means I'm going to have to get rid of that in order to complete the square. So I'm just going to walk through these parts with you. I'm first going to set this equal to 0 because I'm looking for my x-intercepts. And that one, we know that when we have x-intercepts, that we know that y is equal to 0. I'm going to now finish y equals 2x squared plus 12x plus 8. What I'm going to do now is I'm going to move that 8 over to the other side. Minus 8, minus 8. So I have negative 8 plus 2, equals 2x squared plus 12x. Next thing I have to do is divide by 2 to get rid of that coefficient. So I just have an a of 1. Divide this by 2, this by 2. I get negative 4 equals x squared plus 6x. This is again now when I look at this and I say to myself, what could I add here to turn this expression, right now it's a binomial, into a perfect square trinomial? So I think about how I would take half of 6, and that's 3, and I would square it to get 9. If I add 9 to this side, I add 9 to this side. And I know that this is x plus 3 times x plus 3 in factored form. I'm just going to call this 5. I'm going to put like terms together. But I also know that this is x plus 3 quantity squared, and I have 5. Now I'm going to have to square root both sides. So I square root the left, I square root the right, and then I put that plus or minus there. Just as a reminder, because if x squared equals 25 and I square root both sides, I know that x could be either plus or minus 5. So when I write that square root symbol here, I write plus or minus, the 25, root 25 there. Okay, the other thing that I have to do now is I'm going to move this 3 out once I have rewritten this without a radical. So I have x plus 3 is plus or minus root 5. That square root undoes that square there. Then I'm going to move my 3 over, so I have negative 3, minus 3, minus 3. But I'm going to keep the negative 3 first, just so I know that that is not part of my radical. So I know that x is equal to either, my two options are x equals negative 3 plus the square root of 5, or x equals negative 3 minus the square root of 5. The square root of 5 is about 2.2. So this is my exact x-intercepts, exact values. When I ask you to approximate it, or anybody else asks you to approximate it, you are going to be able to say that you are finding about what your radical is worth in order to simplify and know about where your x-intercepts are. So if I were to approximate, the square root of 5 is about 2.2. So I could say x is about negative 3 plus 2.2, and x is about negative 3 minus 2.2. So this means about. This symbol here means approximately. So my two x-intercepts here are about negative 0.8 and negative 5.2. So that means my two x-intercepts on my graph are about there. They're exactly here. All right, so now that we have that out of the way, I want to be able to use this example to be able to guide us into a situation where we just don't want to do any work, really, to be honest. You've heard this a lot this year. We want to come up with a way that we can use an approach every single time without having to do a lot of work. So I'm just going to take you through a different looking equation in standard form. So what we're going to do here is we're going to say, the benefit of looking at an equation like this is to say for any value of A, for any value of B, for any value of C, I can solve and get the x-intercepts without doing any work. This is great if A is not 1. This is great if b is not even, and this is great if it doesn't factor. And it's just great if I want to be able to use this root every single time because it always works. First thing I'm going to do is set this equal to 0, because again, when this is equal to 0, this means that we are finding our x-intercepts. Okay, so I have ax squared plus bx plus c. Then the next thing I'm going to do is I'm going to subtract c from both sides. So I have negative c equals ax squared plus bx. Now I need to get rid of this a on my x squared or my quadratic term. I have to divide everything by a. So I have negative c over a equals x squared plus b over ax. This should feel very familiar. It might start to feel a little bit crazy in a minute, but I want you to just feel like you know how to do this. You move the constants to the other side. This you saw in the last example. I'm just going to divide by that a term. And then, and now I'm just going to have to complete the square. I'm forcing this to become a perfect square trinomial. So now what I need to do is I need to think about half of b over a. Half of it would be b over 2a. That squared, the half squared, would then give us b over 2a squared. Just remember that means that the numerator gets squared and the denominator gets squared. So 2a times 2a is 4a squared. So I'd have to add b squared over 4a squared to both sides. You might be thinking, oh my gosh, what are we doing this for? So if this is feeling like that, then just, watch, but we'll use this in a minute and I think you'll really like it. And otherwise, if you're feeling like this is, you're following, then that's awesome too. What we're going to do is factor the right side of the equation. So just like before, I had x squared plus 6x plus 9. And that became x plus 3 quantity squared. I took half of this, and that what was in my factored form. So I'm going to take half of this, which we already know is b over 2a. So b over 2a, quantity squared. It should seem just like this, just a little bit different. On the left side of the equation, I'm going to do something else. I'm going to make a common denominator. I have a 4a squared and an a, so my common denominator is going to be 4a squared. I'm going to make an equivalent fraction over here. I'm going to say that negative c over a equals what over 4a squared. I would have had to have multiplied this by 4a and this by 4a. So negative c times 4a is negative 4ac. So now I have b squared, because this was the same denominator, minus, and my new numerator now is 4ac. To get rid of this squaring here, I'm going to have to square root both sides. So I'm just going to square root. Remember, I have that plus or minus over here. And then what I'm going to do is I'm going to now say that I want to square root both sides. I'm now going to just want to get rid of my radicals, and then I'm going to want to move this over. So I now have x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. Then I'm going to subtract this. So I have a negative 2b that I'm going to move, negative b over 2a. So I have negative b over 2a. Oh my gosh, I'm so sorry. This is over 4a squared. I'm really sorry about that. Plus or minus. Now what I want to show you here as an aside, one of the many, many cool things about radicals is that if I have a fraction in a radical, like 7/9, what I can do is I can rewrite that as the square root of 7 over the square root of 9. And what that then becomes is the square root of 7 over 3. So I can actually break it apart so I can deal with just the part that would simplify. So now in this part here, I'm going to take the square root of 4a squared, which we already know is 2a. So I have the square root of b squared minus 4ac all over 2a, and that equals x. Because now at this point I have a common denominator of 2a, which is really awesome, I can rewrite this, and instead x is equal to negative b plus or minus the square root of b squared minus 4ac. I'm just moving it all over so that it all has one denominator. Here I have two denominators, and I just want to put it all over the same denominator of 2a. So this is what's called the quadratic formula, and it is totally fantastic. And what we're going to be able to do is every single time we want to start, anytime I want to solve for the x-intercepts of an equation, I can just use the quadratic formula. So let's try an example, and you can get a sense of how great this is to use. Okay, so if I have something, and you can pick whatever you want, which is so awesome, but if I pick y equals 2x squared minus 4x plus 1, that I can rewrite this instead using standard forms, basic equation, basic model here. This lets me know that this is my a, -4 is my b, and 1 is my c. And now I'm going to use what we came up with on the last one. For my x-intercepts, I can use the quadratic formula. -b plus or minus the square root of b squared minus 4ac all over 2a. And now I'm just going to plug these things in. Instead of having a -b, I'm going to have a -4 in there. So I have minus -4 plus or minus the square root of, now this is b squared, so -4 squared minus 4 times, instead of a, it's going to be a 2, and instead of a c, it's going to be a 1. And this is all over 2a, or 2 in this case times 2. This is going to give me, really nicely, this is going to give me my x-intercepts with really no factoring, no graphing, nothing else. Okay, so x is equal to here 4 plus or minus the square root of -4 squared is 16. Be really careful of this minus 4ac. This is where a lot of people tend to make mistakes with their negatives, so just watch that. All over 2 times 2 is 4. So this means that we have x is equal to 4 plus or minus root 8 all over 4. And that, I'm going to simplify this radical here. Square root of 8 is also known as the square root of 4 times the square root of 2, or 2 root 2. So I'm going to call it that instead. So x equals 4 plus or minus 2 root 2 all over 4. So those are my two x-intercepts, which is pretty awesome. Again, hardly any work, and this is what we get. I'm going to take it one step further just to let you know that if you had, for example, here you have this is a factor, has a factor of 2, this has a factor of 2, and this has a factor of 2. So what I can do is I can right now actually also take that common factor of 2 out of all of them, so that we can figure out what this would be in a more simplified form. So let's see here. You'd have, if I divide everything by 2, I'd get 2 plus or minus the square root of 2, because this 2 would drop out, all over 2. Sorry about all the 2's on that. But that would be in simplified form. In approximate form, we'd have 2 plus or minus, instead of the square root of 2, as an approximation is 1.4 to the nearest tenth, all over 2. That means your answers are 2 plus 1.4 over 2, or you have another answer of 2 minus 1.4 over 2. This means you have 3.4 over 2, or 1.7, so that's one of your x-intercepts. And then your other x-intercept would be 2 minus 1.4, and that would be 0.6, so 0.6 over 2, or 0.3. So you can see you have a 0.3 for an answer, you have a 1.7 for an answer, or exact form is 2 plus or minus root 2 all over 2. So again, if you don't know how to derive the quadratic formula, totally not a big deal, but I do want you to see how you can use the quadratic formula. You're going to have to use this to be able to solve any equation to get the x-intercepts, the exact value, as well as the approximates, which you could also get on GeoGebra. Okay, see you soon.